this one, I don't like this graph right away, and if I were here to talk to you, I'd say, why don't I like it? And you would respond, because it's not labeled, and you would be correct. So the first thing I want to do is label this really big. If we have a graph of position or velocity or acceleration, you're going to want to label it because you're going to be very, very angry if you mess it up. I also want you to note, because you would be told this, but the only point of concavity for S of t is at C. So changes concavity, I should put S of t changes concavity at C only. So then you don't think that it's changing it A or at E. Okay, so at which point is the velocity equal to 0? So velocity. Think about this again. If you need to write this every time, that's fine. I've got S of t. My velocity would be the derivative of that, so that's the same thing as S prime. Acceleration is S double prime, or V prime of t. So be thinking about those relationships. The function, first derivative, the second derivative. And by the way, they're all functions usually. At which point is the velocity equal to 0? So on this one, if this is my position function, I really want to know when is S prime of t equal to 0. S prime of t, that's when we have horizontal tangents. Look at this graph, think about when there's horizontal tangents. I see one at E. I see one at D. So two horizontal tangents at B and at D. And I have to justify, and I have to use the graph of S of t. So as S of t has horizontal tangents, so I've got B and D, if S of t has horizontal tangents, therefore S prime of t, or V of t, is equal to 0. So we're really covering all our bases. So we're saying S of t. So S of t is the graph given, so I have to use that. But it's talking about velocity, so you're making the connection. You're showing that you know that velocity is when we've got S prime of t and when that's equal to 0. Okay, next one. Acceleration is equal to 0. Think about what this means in terms of S of t. So acceleration, I know, is the derivative of velocity. But I'm not given velocity, I'm given S of t. So I need to think about it in terms of S of t. S double prime of t is acceleration. You made a chart and cheat sheet over here just to make sure that you're good. Okay, so S double prime of t is equal to 0. So the second derivative, when a second derivative is equal to 0, not all the time, but there's a chance that the original function is changing concavity. So I can see right here, I've got this function that's going from concave down, and then right here it changes to concave up. So it's definitely changing concavity at C, and I told you that before. So I would say at what point is the acceleration, excuse me, equal 0? I would say at C. Acceleration, or A of t, equals 0. Which is also known as V prime of t, which is also known as S double prime of t. That's a lot of information, but you're actually saying you know what you're talking about. But when I justify, I have to use the graph of S of t, because that's what's given. So as S of t changes concavity. Okay, lots to take in, but again, you're making the connection every time. S of t, V of t, A of t. On what intervals is the particle's velocity positive? So again, you're thinking about velocity. Velocity is V of t or S prime. So even without, just knowing that you have that S of t, the graph of S of t, you have to think about, okay, velocity is positive, so V of t is greater than 0 when S of t is doing what? So when S of t, in order to make S prime the derivative positive, S of t has to be increasing. I'm justifying before I even give an answer. So if this is all that you knew, you would still get a point for this because you know actually a lot. Now we can go up to the graph. I can say, okay, well, when is S of t increasing? From negative infinity to b. So this occurs on the intervals negative infinity to b and d to infinity. Let's see, d to infinity. Based on that one, you should be able to get this one also. So if we're talking about velocity as being negative, the same reasoning applies, except it would be backwards. So v of t is less than 0 when s of t is decreasing. This occurs on the intervals. This time I'm going to go from B to D, and that's it. So I guess I should have just said interval. B to D. Okay, now we have to think about this, acceleration being positive. So when is acceleration being positive? But I'm given the graph of S of t. So I need to be thinking about acceleration, not in terms of being the velocity derivative or the derivative of velocity, but in being the second derivative of position. So I've got s double prime of t, and I want to know when that is going to be positive. Think about this. When s double prime is positive, that means s of t is concave up. So I'm going to actually write that first. Acceleration is positive when s of t is concave up. So I'm justifying this even before I get to the next part. I feel like I'm going to sneak away. I can do the same thing down here, even though I didn't answer this question yet. When is acceleration negative? At is less than 0. When s of t is concave down. Okay, so concavity, let's go back up, see when this happens. Concave up, really happy, you see where it's changing. Oh, up, I'm smiling, concave up. From c to infinity. So this occurs on this interval from c to infinity. Concave down, be negative infinity to c. Take a minute, talk to each other, make sure you've got this page.